few months back, a couple of engineering professors built a collaborative water Rube Goldberg machine at the American Geophysical Union fall meeting. This water science pop-up was demonstrated on the streets of San Francisco, and I was lucky enough to be one of the collaborators who was invited to design a piece for the display. It's a quick project, but it came out working really well, so I wanted to share it with you guys. I'm Grady, and this is Practical Engineering. On today's episode, we're taking a look at an automatic siphon. You've probably made a siphon before, and if so, you probably have at least a cursory understanding about how it works. The fundamental principle is based on hydrostatics, or the relationship between the height of a fluid column and its pressure. At the highest point in a siphon, the pressure is actually lower than atmospheric pressure, also known as a vacuum. This allows atmospheric pressure to push the water up over the peak of the siphon, so gravity can carry it the rest of the way. For most situations, that's enough theory to describe your typical siphon. It's a very convenient way to drain a reservoir or transfer a liquid without a pump. But a siphon still requires some help to get started, also called priming. There's the classic way of using your mouth to prime a siphon, but that only works for short, small tubes and with liquids that are safe for human consumption. Not that it stopped countless people from ingesting a mouthful of gasoline trying to borrow some from a vehicle or drain the tank on a lawnmower. For larger applications like draining a pond, you have to get a bit more creative. The typical way to do this is to have a valve at the downstream end and a port at the crest of the siphon. With the valve closed, you can fill up the pipe with water from the port. Close the port and open the valve, and with any luck, your siphon will pull out any air bubbles and start draining the pond. But there are certain cases where it would be nice to be able to create a siphon without any intervention. A self-priming or automatic siphon, the next level of siphonry. And this project is an example of just that. This is a demonstration of a bell siphon, which I built out of an acrylic sheet and a piece of clear pipe. A bell siphon has three basic parts: a reservoir, the bell, and a riser. Here's how it works. As the water fills the reservoir, the surface of the water is equally exposed to atmospheric pressure. Outside the bell, it's exposed to the atmosphere from the open top of the reservoir. And inside the bell, it's exposed to atmospheric pressure through the empty riser tube. As the water rises, it eventually forms a seal over the riser tube inside the bell, closing off the bell's connection to the atmospheric pressure. As the water falls through the riser pipe, it creates a vacuum inside the bell, drawing more water from the reservoir up and out. Eventually, the water level in the reservoir drops below the bell, allowing air to enter and breaking the siphon. As the remaining water drains from the riser, the pressure inside the bell returns to atmospheric and the process starts all over again. Here's a clip showing the entire process. This is the same mechanism used in the Pythagoras cup, one of the oldest practical joke devices. But there are more pragmatic uses for a bell siphon too. Many septic systems use a similar device to dose effluent into a leach field, which is more effective than just allowing it to constantly drain. Bell siphons are also common in hydroponics and aquaponics to create a cycle of wet and dry for plants. Finally, bell siphons are found in public restrooms. YouTuber Big Clive did a teardown of a multi-stage bell siphon used to automatically flush urinals.
This is a lot more complex than I thought it was. It's not immediately obvious to me how this works.
I'll link his video below if you want to check it out. A siphon is a classic example of science defying our immediate intuitions. Water flowing uphill with no pump or moving parts. And a bell siphon is a perfect extension of that, with its ability to prime itself, completely eliminating the need for any intervention at all. Thanks to Rolf and Pete Marchetto for inviting me to collaborate on this project, and thank you for watching, and let me know what you think. If you're new to the channel and like what I'm doing, don't forget to subscribe. You can also visit my website at practical.engineering to read more about my projects or buy a t-shirt. If you really like what I'm doing, you can support the channel on Patreon. I use that funding to improve the quality and quantity of videos. You can also follow the day-to-day happenings in the shop on Instagram or Facebook. Finally, all my past videos are in playlists based on different fields of engineering, so go check them out if you haven't already. Thanks again for watching, and let me know what you think.